I'm going to talk about finding limits at infinity of non-rational functions. So functions that are not rational may approach different horizontal asymptotes to the right and to the left. You can still use the same procedure as before. So we're going to talk about functions with two horizontal asymptotes, and we want to determine each of the limits to find the horizontal asymptotes. So we have the function 3x minus 2 over the square root of 2x squared plus 1. And these functions are the same. In letter A, we're trying to find it as x goes to positive infinity. In letter B, we're looking at x goes to negative infinity. So the first thing to notice here is that we have a radical symbol. So when we do that, we want to realize that this is not a rational function, so we're going to treat it a little bit differently. What we want to do first here is divide both of these by x. And this is really going to become now the limit as x approaches infinity of 3 minus 2 over x over the square root of 2x squared plus 1 over x. Now we're going to do a little trick here with this square root so that we can actually divide these two. And what we're going to do is we're going to let x equal the square root of x squared. And we're actually going to let it equal the positive value because when x goes to infinity, we know x is greater than 0. So these things all have to match up. So when x is going to infinity, that's positive, so x is greater than 0, meaning we're going to let x be the positive square root of x squared. And so what that does for us now is we have the limit as x goes to infinity. The numerator is still 3 minus 2 over x. The denominator now becomes the square root of 2x squared plus 1 over the positive square root of x squared. And so now I can divide these two and put them under one radical symbol. Just like this. So 2x squared plus 1 over x squared. And I can rewrite it again as the square root of 2 plus 1 over x squared. And again, this is the limit as x goes to infinity. So as we look at this, the limit as x goes to infinity, this part right here is going to go to 0, and then this part right here is also going to go to 0. So in our limit, we can basically get rid of these, and so we're left with 3 over the square root of 2. So we know that this function here has a horizontal asymptote at 3 over the square root of 2. Now that was as we approach infinity. So as we move right, this is what our value goes to. In our second example, now we're going to negative infinity. So we still do the same process where we divide by x. Okay, so we still have this guy right here. But we're going to negative infinity now, and this is 3 minus 2 over x over the square root of 2x squared plus 1 over x. Now in this case, since our limit is going to negative infinity, we know x is less than 0 this entire case. And so what we're going to do is let x equal the negative square root of x squared. Okay, and that's really, really crucial. So if we're going to negative infinity, we're going to let x equal negative square root of x squared. Okay, so we can rewrite this one here, 3 minus 2 over x. And then this will be the square root of 2x squared plus 1 over negative square root of x squared. All right, and we'll rewrite this again, and we'll get 3 minus 2 over x over, now under one radical, negative, okay, from that negative right there. And this is going to be 2x squared plus 4 over x squared. So now we'll write our limit as x approaches negative infinity. We get 3 minus 2 over x over the negative square root of, let's see, this would become 2 plus 4 over x squared. And again, we can see these rational functions inside here are going to go to 0, and so they basically cancel out there because they went to 0, and so in this case we're left with negative 3 over the square root of 2. So as we approach negative infinity, the horizontal asymptote is negative 3 over the square root of 2. So let's take a look at our graph here, and then we can verify this. So here is our function. As we go to infinity, we can see we're approaching here, and this is 3 over the square root of 2. And as we go to negative infinity, notice we're approaching a different horizontal asymptote, and this is negative 3 over the square root of 2. All right, let's move on. Now it turns out when you divide by your radical, you can see that underneath here, this is the square root of an x squared. So when we're dividing by a square root, we can almost think of our Bobo button eats DC, and we can see that this would be a 1, and this is effectively the same as a 1 here. What we want to remember here is that x is approaching infinity, so x is greater than 0, meaning our answer here is going to be the positive. And so when the exponents are the same, we have DC, or divide coefficients. So here the coefficients are 1 and the square root of 9. And so this limit really is 1 over the square root of 9, which is 1/3. Now in this case it's the same function, but now we're going to negative infinity. So we can still see that effectively the exponents are the same. So we want to divide the coefficients. So here and here, so 1 and the square root of 9. But remember, x is going to be less than 0. So when you have that square root symbol, we actually get negative. So it's 1 over negative square root of 9, or 1/3. So let's take a look at that graph here and verify that's what's going on. So here is x plus 3 over the square root of 9x squared minus 5x. As we go to infinity, you can see we're approaching 1/3. And as we go to negative infinity, also approaching here negative 1/3. So the Bobo button eats DC still works with radicals in the denominator. We just have to think a little bit differently. If we're going to infinity, then we keep this guy positive. If we're going to negative infinity, then we change this to negative. Our next examples here don't have any fractions in them, and they do have radicals, however. And so for these, we're going to take a little bit different approach. So our hint is let the expression be a fraction whose denominator is 1 and rationalize the numerator. Okay, so what we're actually going to do here is multiply by the conjugate of this guy. So we're going to multiply the whole function by 3x minus the square root of 9x squared plus 3x. And so that we're not changing the function, we're actually multiplying by 1. So we need to do the same on the top and on the bottom. Okay, so that's our first step. Multiply by the conjugate in the numerator and the denominator. So this now becomes the limit as x goes to infinity. When you multiply by the conjugate, remember, we get the square of the first one, so that's really 9x squared, minus the square of the second one, which is just 9x squared plus 3x. So effectively, it gets rid of the radical in the numerator. And what it does is it puts the radical in the denominator. So we're still left here with 3x minus the square root of 9x squared plus 3x. And let's go ahead and simplify this. So distribute the negation to both of these. So 9x squared minus 9x squared is 0, and then minus 3x. So we have minus 3x in the numerator, and then 3x minus the square root of 9x squared plus 3x in the denominator. From here, we would follow the same steps that we did before, where we divide numerator and denominator by x, and notice what that does for us is it gives us our constant in the numerator. So this becomes negative 3 over 3x minus the square root of 9x squared plus 3x, and we still have that divided by x here. Okay, so the x canceled on top, and it doesn't in the bottom. And we're just going to rewrite this again. Okay, we're going to go 3x over x, so that's just 3. And we're still going to have minus the square root of 9x squared plus 3x divided by, well, here's that situation where we have the square root of x divided by x, and we want to be able to combine them. Here comes the trick. We have the square root of 9x squared plus 3x divided by x. Now we need to be able to divide these together, and so we're going to let x equal the square root of x squared. Now we have to remember, since we're going to x going to negative infinity, we need to make sure that this is the negative square root of x. So we're going to change x into the negative square root of x squared here. Okay, so let's go ahead and rewrite this now. So we have negative 3 over 3. Well, let's see, it was minus, and we divided by a negative. So those two things combine to be plus. So now it'll be the square root of 9x squared plus 3x over x squared. So this is our last step. So we're going to write the limit as x goes to negative infinity of negative 3 over 3 plus the square root of, well, 9x squared over x squared is just 9, and 3x over x squared is 3 over x. Now looking at this, when we take our limit, the 3 over x is going to go to 0. So it effectively drops out. And so our final answer then, you can see all we have here is constants. So we have negative 3 over 3 plus the square root of 9, which is negative 3 over 3 plus 3. And negative 3 over 6 is negative 1/2. Let's take a look at that graph. So right here you can see here's our 3x plus the square root of 9x squared plus 3x. And as we go to negative infinity, we can see that the graph is going to negative 1/2. So we do have a horizontal asymptote here at y equals negative 1/2. Alright, I want you to try letter F on your own. Go ahead and pause the video and come on back to check your work. Alright, welcome back. So you should have multiplied here by your conjugate. And then when you divide by x, you actually divide by the square root of x squared. And you keep it positive because we're going to infinity. So you keep that positive. When you substitute that in, you can see that this part right here would be the square root of 1 minus 6 over x. This part would go to 0, and the square root of 1 is 1. And so this becomes 6 over 1 plus 1, and 6 over 2 is 3.